Good evening. My name is Lloyd Curtis Smith, and today I will be discussing with you Internet Protocol version 6, or IPv6, in a presentation titled IPv6, the Internet's most anticipated protocol. Here is a brief overview of the topics that will be discussed today. I will start this presentation off with discussing what exactly is Internet Protocol version 6. I will go over the many features of Internet Protocol version 6. I will do a comparison between Internet Protocol version 4 and Internet Protocol version 6. I will discuss the advantages and disadvantages of Internet Protocol version 6. I will also go over a brief timeline of some important dates within the deployment and implementation of Internet Protocol version 6. And lastly, I will cover some adoption statistics. Despite efforts to extend Internet Protocol version 4 addressing with the introduction of private IP addressing, network address translation, or NAT, one private IP to one public IP conversion, and port address translation, which is many private IPs to one public IP conversion, the world is still en route to an inevitable path. Internet Protocol version 4 will eventually be completely exhausted. This inevitable depletion led to the inception of Internet Protocol version 6, which provides an immense amount more IP addresses per person than its predecessor, as well as many other features. While Internet Protocol version 6 presents solutions to some of the design flaws of Internet Protocol version 4, it still has yet to be completely adopted worldwide. In recent years, it has slowly started becoming mandatory for particular entities to adopt this protocol. With this mandatory push towards its adoption, it is imperative that it is known what all the adoption encompasses. Opposed to Internet Protocol version 4, Internet Protocol version 6 has built-in security. Its address space is composed of 128 bits instead of 32 bits. It has hexadecimal characters for the much longer addressing format, and etc. What is IPv6? Internet Protocol version 6 is a 128-bit IP addressing protocol that Internet Engineering Task Force, or IETF, began engineering in 1994 to address the shortcomings of Internet Protocol version 4. The first official Internet Protocol version 6 request for comment, or RFC, which was RFC 1883, was published December 1995. Here are the Internet Protocol version 6 features. First, I will cover the list of features, and then I will go into detail about some of the features in this list. Alright, so the most common feature that everyone is aware of is the 128-bit address space, which is full of hexadecimal characters. Then there's the improved multicast addressing. There's the efficient and hierarchical addressing and routing infrastructure. With IPv6, IP addresses are distributed by regional internet registries, or RIR. It has built-in security. It has mobile phone network support, which is referred to as Mobile v6. There is stateless and stateful address auto configuration. There is a new header format that is introduced with Internet Protocol version 6. There's a neighbor discovery protocol, which is also introduced within this Internet Protocol. It provides extensibility, improved quality of service support, and it provides what is called multi-homing. So of course, with the extended address space, there are a substantial amount more IP addresses available for internet usage. The improvement of multicast addressing removes the need for send messages. Now essentially the same can be done by sending one message to many, opposed to sending one message to all. Alright, the efficient and hierarchical addressing and routing infrastructure is pretty much the design of Internet Protocol version 6 global addresses to create an efficient, hierarchical, and summarizable routing infrastructure that addresses the common occurrence of multiple levels of Internet service providers. This allows the backbone routers to have much smaller routing tables. Alright, so IP addresses being distributed by regional Internet registries. A regional Internet registry is an organization that manages the allocation and registration of Internet number resources within a particular region of the world. So, with IPv6, the IP addressing distribution has been broken up into the following regions. The African Network Information Center, for Africa, is referred to as AFRINIC. The American Registry for Internet Numbers, RN, which is for the United States, Canada, several parts of the Caribbean region, and Antarctica. Then there is the Asian Pacific Network Information Center, APNIC, which is for Asia, Australia, New Zealand, and neighboring countries. There is also the Latin America and Caribbean Network Information Center, LACNIC, for Latin America and parts of the Caribbean region. Then there's RESU, IP, European Network Coordination Center, which is RIPE, NCC, for Europe, Russia, the Middle East, and Central Asia. Okay, so built-in security. As we all know, Internet Protocol version 6 Internet Protocol version 6 has built-in IPsec support, which allows end-to-end encryption as well as authentication. This also promotes interoperability between different Internet Protocol version 6 implementations. Alright, the mobile phone network support. Mobile v6 allows for mobile devices to move from one network to another and still maintain existing connections. Alright, so to simplify host configuration, Internet Protocol version 6 supports both stateful address configuration, which is the address configuration in the presence of a DHCP version 6 server, and stateless address configuration, which is the address configuration in the absence of a DHCP server. More information about the stateless address configuration is that hosts on the link automatically configure themselves with IPv6 addresses for the link, which is considered a link local address. This happens even in the absence of a router. Hosts pretty much configure themselves with link local addresses and communicate without manual configuration. Okay, so the new header format that is introduced in IPv6 is that the header is designed now to minimize header overhead. This is achieved by the moving of both non-essential fields and option fields to extension headers that are placed after the IPv6 header. The streamlined IPv6 header provides more efficient processing at intermediate routers. IPv4 headers and IPv6 headers are not interoperable, and the IPv6 protocol is not backwards compatible with the IPv4 protocol. So So the new header is only twice as large as the IPv4 header, and although the IPv4 addresses are 4 times as large as the IPv4 address. Alright, so the neighbor discovery protocol. The network discovery protocol uses Internet Control Message Protocol (ICMP) messages and solicited node multicast addresses to determine the link layer address of a neighbor on the same network, to verify the reachability of a neighbor and track neighboring devices. The extensibility feature is simply the fact that Internet Protocol version 6 can be extended for new features by adding extension headers after the IPv6 header. Alright, improved QoS support. Now, in the header of Internet Protocol version 6, there is what is called a flow label. A flow label allows routers to identify and provide special handling for packets that belong to a flow, which is a series of packets between a source and a destination. Because the traffic is identified in the IPv6 header, the support for QoS can be easily achieved even when the packet payload is encrypted with IPsec. Alright, and lastly, multi-homing. Multi-homing is the connection to more than one internet service provider. This pretty much allows for redundancy, load sharing, and a lot of other features. Well, a lot of other. Alright, so here's a small comparison between Internet Protocol version 4 and Internet Protocol version 6. So, IPv4 only offers a 32-bit addressing space, which is approximately 4,294,967,296 addresses available. It does class full addressing, which has two-level address hierarchy, which means part of the address is the network ID, and the rest of the addressing is the host ID, unless there's subnames, which there can be a 3-level hierarchy. There are 5 classes, which is A, B, C, D, and E. IPv4 allows for broadcast addressing, which is a message from one to all, unlike Internet Protocol version 6, which doesn't have broadcast addressing, as earlier mentioned. In Internet Protocol version 4, we have what is referred to as manual configuration, which is the need for DHCP to lease out the IP addresses, or the static assignment of an IP address. IPv4 also uses network address translation, which is referred to as NAT, and that's the other version of PAT, which is port address translation. These are two of the methods that have been used to extend Internet Protocol version 4 addressing. Alright, and then also there is no inherent security and authentication in Internet Protocol version 4, unlike Internet Protocol version 6, which has built-in IPsec. In regards to Internet Protocol version 6, the 128 address spacing offers 2 to the 128 IP addresses. There is built-in encryption authentication due to IPsec. There's auto configuration, which I talked about earlier, in which the device can pull a link local address. It has what is referred to as anycast addressing, unicast addressing is a single address which is assigned to multiple nodes, which means a packet sent to an unicast address is delivered to the first available node. This provides load balancing and automatic failover. There is also the flow label field, which, as discussed earlier, improves the quality of service support. And then there's an improved header. There is no options, no field checksum, no fragmentation, which allows for quicker transmit. Alright, so here are some of the advantages of utilizing Internet Protocol version 6. One, which is the built-in security and authentication, as well as providing of end-to-end security with the use of IPv6. You have 3.4 times 10 to the 38 IP addresses available. There is scalability, since there's a substantial amount of IP addresses. This will assist with the Internet of Things. And then, not to mention, every person will have a total of, currently, it would be estimated to be 7.7 times 10 to the 8 IP addresses available to every person. It also offers extensibility due to the extension header available in the IPv6 packet. There is mobility, which is earlier mentioned, like Mobile v6. There's more secure name resolution, and the name of the SEND protocol, which stands for Secure Network Discovery. It is designed to counter possible threats of the Network Discovery Protocol. It does so by defining a set of neighbor discovery options and 2 neighbor discovery messages, as well as defining a new auto-configuration mechanism to establish address ownership. It has additional security features such as an authentication header, which is in the extension header, an encapsulation security payload, and it also does network discovery is another advantage, which was earlier mentioned. Some disadvantages is trackable UE64 addresses. UE64 addresses are what EUI stands for is the Extended Unique Identifier. Extended Unique Identifier 64 address allows the host to assign itself a unique 64-bit IPv6 interface identifier, which and the format of the address is obtained through the 48-bit MAC address. So with this, an attacker can take the information provided and could potentially reveal the make and model of a remote machine and use that information to target attack. Alright, so there's unauthorized Internet Protocol version 6 clients. This disadvantage is due to how easy it can be to not notice that a user has IPv6 enabled. And so due to the extended capabilities of IPv6, as well as the possibility of an IPv6 host having a number of global IPv6 addresses, the potential provides an environment that makes network level access easier for the attacker if the access controls are not properly deployed. Then there are the network discovery vulnerabilities. cons about network discovery is that it can allow or cause the IP packets can be caused to flow in unexpected places. Um, which can cause the denial of service to be one of the results. These attacks could allow nodes to intercept and optionally modify packets destined for other nodes, while it is protected by IPv6. Then there's the increased complexity that comes with the building out or the planning of a internet protocol version 6 deployment. There's the increased complexity of the environment to deploy a dual stack technology. There are transition tool vulnerabilities, there are vulnerabilities with tunneling. There are vulnerabilities with the thing about tunneling is like if Internet Protocol version 6 is tunneling through Internet Protocol version 4, it can allow Internet Protocol version 6 information or packets to get into the network going unnoticed. Alright, so other things would be the extension header could cause degradation of the network because of the size, and then there's larger network segments, which is a good and bad thing. The large network segments give attackers a lot of IPs to choose from, and also makes it harder to scan. Alright, so here's the implementation timeline. So December 1995, the first RFC for IPv6 was introduced. Alright, then in December 1998, there was a change in the header format which resulted in another RFC. Excuse me. So in 1999, RIRs began allocating IPs. Then fast forwarded to 2011, that'll be World IPv6 Day. World IPv6 Day was when the government as well as other entities went on a 24-hour period of utilizing Internet Protocol version 6 as a test. Then in June 2012, that was World Internet Protocol version 6 launch day, in which the same was done, however, it was more of a permanent fix or permanent use for some to switch over to Internet Protocol version 6. Then September 30th, 2014, there was a government mandate on government agencies to be utilizing Internet Protocol version 6. So as you see from its inception to 2014, there has been some type of push to utilize Internet Protocol version 6. However, the main infrastructure for the Internet is still Internet Protocol version 4. Alright, so here are some adoption statistics showing the top 13 countries in regards to the percentage of Internet Protocol version 6 being deployed. As you see, Belgium is the leader with 35.1%. Greece is second with 23.1%. And America is third with 20.8% deployment of Internet Protocol version 6. Here are some continued statistics. These statistics show the networks that have deployed Internet Protocol version 6 and the percentage. So as you see, the top network with Internet Protocol version 6 deployment is Comcast Cable with 42.7%. Right behind them is AT&T with 42.6%. As you see, Time Warner Cable is at 21.5%, and Verizon Wireless 73.6%. Alright, yeah, that looks a little funny. Alright, so these statistics for the networks, it is ranked based off of the volume of IPv6 requests to Akamai. Alright, and here's the IPv6 adoption taken from Google's website, which is a continuous measurement of the availability of IPv6 connectivity among Google users. As you can see, from January 2009 to January 2016, there's been around a little over 12% um, change or increase. There are